Hey folks, welcome back. This is Joel, and in this video, we'll start talking about Aruba's ST branch. Now, some of you might already know I have started exploring the Aruba's ecosystem since last couple of months. They've got wide variety of solutions across various verticals like campus, data center, security, and so on. I obviously wanted to start with the ST branch because SDN is the space where I have worked over the last couple of years, and it was also pretty easy to set up this whole topology. Okay, so that being said, this is going to be an introduction video, so we will not be doing any major hands-on. We'll actually spend maybe the first 10 minutes just talking about the solution, right? A quick overview of sorts. And the next few minutes we will talk about the topology which I have set up. I think you can have a look over here, right? So this is going to be the topology. So we'll talk a little bit about the topology, and I'll also give you some tips on how to set this up, what are the prerequisites. And once we are done with that, we'll wind up, we'll come back in the next video and we'll actually start bringing up these devices and bringing up the whole SDN solution from scratch. All right. Okay, to start off, I think I've got a few links here. Let's open them up. So Aruba has this very cool validated solution guides. And as you see on the left hand side, they've got the guides for campus, data center, and the SDN technologies. So we will mainly be concentrating on the ST branch design section here over the next 10 minutes to kind of understand the solution a bit. We will obviously not be doing very in-depth analysis right now. We will do that while we do the labs. Okay. To start off, let's go to the section which is the Edge Connect ST branch over here, right? And let's try to just understand, right? So what do you kind of understand when you just see the word ST branch, right? So this was something very new to me as well, because I have worked on SDN, right, in data center, right. We also have flavor of SDN in the LAN side, right, which was SD access solution in the Cisco's world. We also have talked about SD WAN, right, on the channel, which was the Cisco's Viptela solution, right. But SD branch was something something new, at least from a terminology perspective, right? But actually, it's pretty simple. What does SD branch mean? It basically means it is SD LAN, right, plus your SD WAN, right? It's just a combination of these two things, which and you have a convergence of sorts, right? And that's where the term SD branch comes in. Now, why do you have why do you have a combination of these sorts, right? Let's try to dig that. Now, when you think of a branch, right, what comes to your mind? It can be a sales office, it can be a small manufacturing unit, right? It can be even a store, right? Maybe a small retail store, right, which can also constitute a branch. Now, again, when you imagine a branch, you've got a small LAN over there, right? You will need your typical wired connections, you would need your typical wireless connectivity, right? You would probably also need a small IDS IPS, a small firewall of sorts, if you have some filtering which you want to do, right? So that all constitutes a LAN. So how do you bring in the whole SDN flavor to that LAN? That's your SD-LAN, right? SD-WAN, I think we again have spoken about SD-WAN in detail previously, but to just jog your memory, what are some of the two important things, right? Two important use cases or problems it is trying to solve. One is trying to kind of get around the complexity of MPLS, right? So MPLS circuits takes a lot of time to kind of bring up, right? You also have cost involved, right? Higher cost involved when it comes to MPLS circuit. So there are a lot of customers who are trying to offload the traffic from MPLS to a much cheaper options like the internet, right? And trying to use those transports. So SD-WAN kind of enables you to do that. Second thing is backhauling, right? So when you see the word backhaul, right, what does it bring to your mind? Most of the applications, we are in 2023, right? Most of the applications are moving to the cloud, right? And especially with the adoption of zero trust and so on, this has become quite prevalent. So nowadays, you will rarely see architectures where you have all the traffic from the branches being tunneled to head end, which is like a data center, right? You'll rarely find that. Most of the applications, because they are on the cloud, the network engineers prefer to kind of directly exit the traffic, right? Locally exit the traffic from the branches and go on to the cloud and do some kind of obvious edge filtering, or do some kind of filtering on firewalling on the cloud as well, right? But predominantly people prefer to kind of not backhaul the traffic all the way to the data center, rather send the traffic directly to the internet, since most of the applications are residing on the internet. Now these two are major pain points which SD-WAN kind of came into solving it, right? And that's kind of what it's been doing for the last 2 3 years. There are many vendors out there. You've got Cisco, you've got Aruba, you've got Fortinet, and there are quite a lot of solutions which are providing the whole SD-WAN as a solution. So coming back, I think now we understand the whole reason behind SD branch, right? When you think of SD branch, think of it as having a solution which will help you to bring up a branch, right? A small branch, a medium branch, a larger branch, but at the same time, something which is not just answering your WAN needs, but also the LAN needs, right? Trying to answer how do you bring up a branch, how do you bring up the wired connectivity, wireless connectivity, how do you do a little bit of filtering, IDS, IPS, all of this with few clicks in a software defined way. That is what SD branch is trying to solve. Okay, so now that we got that cleared, let's try to see before we now that you understand SD branch also has a flavor of SD-WAN, let me bring up a very important point and kind of answer your query, because on the left hand side you might see that there is a separate section called SD-WAN, right? Edge Connect SD-WAN. So don't confuse this SD-WAN with whatever we spoke just now. So this SD-WAN, what you see, the Edge Connect SD-WAN, is actually pertaining to another product, right, which is Silver Peak, right? So Aruba also has another solution and product around the Silver Peak acquisition, and the Edge Connect SD-WAN kind of points to that. We will not be talking about this one in this video or in this series. We will probably do that in future, but right now we are mainly concentrating on SD branch, which also has a small flavor of SD-WAN to it, has some of the typical SD-WAN use cases which we will be obviously covering, but these two are separate solutions, right? The SD branch and SD-WAN are separate solutions, and we'll be mainly concentrating on the SD branch. Okay, so now that you know that, let's actually come down to what does what are various components of this solution, right? So let's see if I have a diagram here. Yeah, so there you go. I think this is a pretty good diagram, right? So to explain this, right, what are some of the components, right? You see here, let's start from the underlay. Whenever you talk about SDN solution, you always have an underlay, you always also have an overlay, right? So in the underlay you have typically what? You've got your circuits, right? You've got your transports, right? Which is your it can be your internet, it can be your LTE, it can be MPLS, right? So you have your transports, and then you also have your routers or the edge devices, right? So here you can see again you have different flavors of edge devices in case of Aruba, right? In fact, there are mainly two flavors, I would say. One is your branch gateways and the other one is your head-end gateways, right? Or head-end gateways are also called as VPNCs, but predominantly these are the two flavors, right? So head-end gateways, think of it as those devices which generally reside on the hub side, right? They are basically the devices where the VPN tunnels are going to terminate, right? Terminate from all the various branches. So they are like, think of it as an aggregated hub of sort. So that's your head-end gateway, that's your VPNC. Branch gateways are basically those edge devices which are going to reside in your branch offices or your stores or your maybe the sales side, whatever you have, right? So those are your branch gateways from where generally your traffic is going to be generated, right? The users are going to sit in, right? That's your branch gateway. You also have the virtual form factor. Whatever we spoke now are physical form factors, but you also have virtual form factor, which is your virtual gateway. Now these guys generally sit maybe in your ESXi. This is they can also sit in your cloud, right? So which is AWS, Azure, GCP. They can generally sit there, and that way you can have a multi-cloud strategy, right? You can basically create a hub on the cloud and then connect all your branches onto the cloud and do all that fun stuff. So that's another flavor. And the last one is you also have micro branch. This is again a very typical use case for an extremely small site of sorts, right? So micro branch, think of it as an AP, but then with few extra LAN ports of sorts, right? So that way you can get wireless and wired right from the single box, but at the same time it also has the SD-WAN capability. So you're getting the whole SD-LAN and SD-WAN out of a small AP, right? That way you can kind of use this for smaller use cases like your home office and so on, right? So that's another flavor. Now there's one more important component, right, which kind of puts all of this together, right, puts all of this into perspective, is your what you see here on the center. This is kind of like the main part of the whole solution, which is your Aruba Cloud, right? Or in fact, in this particular scenario, I would basically call it as Aruba Central, right? So Aruba Central is actually the think of it as a cloud-based, a SaaS platform, which does everything for you, which does the management, which does the orchestration, does the assurance, monitoring of your whole solution, and so on, right? So that's why this whole solution fits in so beautifully for customers, especially those customers who have such kind of use cases, right? Like widely deployed, lot of number of branches across the country, across the continent, right? And they want a single pane of glass to do what? To do the LAN as well as the WAN, right? To manage, monitor, orchestrate their LAN, that is do some of the most simplest things, right? For example, create a SSID and advertise, broadcast that SSID at maybe 30 of your sites with a few clicks. You can do that. You want to kind of create a WAN policy or traffic steering policy, right, and deploy it at maybe 50 of your sites with few clicks. You can do that, and all of this is possible because you have this centrally kind of administered, monitored, orchestrated solution, and it is sitting on the cloud, right? So now if you again I always like to compare solutions, right? When I'm learning a new solution, I like to compare it with the solutions which I've already learned. So if I try to compare this with my knowledge of other SD-WAN vendors out there, like for example Cisco's Viptela solution, which we have covered on the channel, right? You will start seeing a little bit of similarities. Obviously you've got the from a devices perspective, I think you can already start seeing similarities. You've got the edge devices, you've got the transport. The main difference which I see here is in case of Cisco's Viptela solution, we had a dedicated control plane. Like we had a on-prem type of a control plane, right? We normally had what we call as the vSmart over here, and all the edge devices, they used overlay protocol, something called as OMP, right? OMP was the protocol which was used, and all the edge devices used to kind of use this control plane protocol, right, to talk to the vSmart, right? The vSmart was then orchestrating the tunnels between the devices, and the OMP was obviously the protocol over which all the routes, right, for whatever the routes over here on the LAN side, right, they were redistributed into the OMP, and once the routes are learned on the other side, they were redistributed back from OMP to, I don't know, maybe a OSPF and so on. So that was the architecture which was there in case of your Cisco's. Here also there are similarities, right? So in this case the main difference though is this control plane resides on the cloud, right? You don't have to manage a separate appliance for it. You don't have a separate vSmart of sort. The control plane, right, is going to reside on the cloud, which means as soon as you go and orchestrate it, right, the control plane is spun up. You still have like a overlay protocol, right, which is I think these guys call it OAP here, right? You still have a overlay protocol. So the rest of the architecture is still the same. I mean, you have all your LAN, right, subnets which are going to be redistributed into this overlay. It goes all the way to the control plane. The control plane acts like a BGP reflector of sorts based on the policies whatever you're configured, and the routes are basically learned right from the OLE protocol onto the other edge devices, and from there they are redistributed into whatever protocol, whatever IGP you're running, behind the edge devices, right? That logic is still the same. The main difference is here, you will see in the control plane perspective, the main difference here is everything is happening on the cloud. You don't have things like a vManage, you don't have a vBond, you don't have a vSmart, a dedicated appliances which you would have the extra burden of managing, maintaining, upgrading. Here everything is happening on the cloud. You as a network engineer, you come in the morning, you open up your console, your central, right, the platform which is here, and this is going to be the place where you're going to do all your work, your day zero work, your day one work, day two work, all the implementation, deployment, managing, monitoring, everything happens here. It also acts as the control plane, right? So all the devices will talk to it, get the routes, build the tunnels, and so on, right? So that's the key unique thing. From the data plane perspective, I think there are a lot of similarities. Again, you still have the same IPsec tunnels, right? So you have different type of transports here, MPLS, internet, LTE. So over those transports, right, the edge devices will automatically create those IPsec tunnels, right? So once you have those IPsec tunnels, then it's very easy to send the data traffic on top of on it, right? So so those are some of the similarities and differences between this solution and whatever we have already covered on the channel. You have more details over here, so maybe we can quickly skim through those. You can read about this. This is again all publicly available information. I'll share the link so that you can read a bit about this. But alright, so we can now review the components which we spoke of. As you see here, Central is probably one of them, right? Then we already spoke of Central. Orchestrator, we already spoke of that. Orchestrator is just a component which is going to reside in the Central. Maybe there is a better diagram here to kind of show that, right? So yeah, as you see here, this is the orchestrator, tunnel orchestrator, right? And like we spoke, its main job is to create those IPsec tunnels across various transports, right? There are certain rules that a tunnel which is created via the MPLS connection here should terminate on the MPLS on the other side, and so on. You can read about those rules and over here, but ultimately its main job is to create those IPsec tunnels, those data tunnels on the overlay, which is where the traffic is going to finally get encrypted and be sent across the sites, right? Then if you scroll down, if I'll have the route orchestrator, right? So as you see here, the main job of this guy is again to make sure that the routes, right, the subnets, in fact, right, I use this pen, the subnets, right, as you see, the connected subnets, or maybe you have dynamic routing, IGP like OSPF and so on. So all those routes are sent all the way to the orchestrator, and the route orchestrator will act like a BGP route reflector of sort, and it will then send the routes to the relevant sites based on whatever control policies you have put here, right? Whatever route maps and so on, all the information, whatever you have configured on the route orchestrator, it is going to push the routes onto the remote sites based on those policies, right? Again, that's mainly that. What else do we have here? We already talked about the components, the various components that make up this, right? Just let me spend a minute over here, right? Because when you talk about the when you talk about the Aruba's ecosystem, if you're very new to it, right, it might take you it might take you a little bit of time to get used to it. But when you look at Aruba's ecosystem, they've got the obvious wireless. They are like a market leader in the wireless space. They've got like very cool APIs and so on. Then they also have a lot of products on the access and the core layers, right? Basically the switching, right? They've got AOS switches. Then they also have the newer AOS CX switches, right? So again, if you're coming from the Cisco's world, nothing new here. Your typical access points, your typical layer 3 switches which you have. One important thing which I find, again coming from the Cisco's world, what I find something unique here is the gateways, right? So they have a lot of functionalities on these gateways. Yes, we are right now talking about SD-WAN, so we are talking about the SD-WAN capabilities, but the gateways over here, they are kind of like, think of them as multi-talented entities, right? They can do a lot of things. They can act as a wireless controller, right? They can do the wireless controlling controller capabilities, right? They also can terminate wired tunnels, right? So the wired traffic which comes from any of these access switches, you can create what they call as dynamic segmentation. So you can create tunnels all the way to this gateways, and you can do certain policy enforcements. You can do firewalling, you can do IDS IPS, so you can do like a wired security policy enforcement as well, right? So they have a lot of they're like multi-function gateways, right? You can do SD-WAN, you can do wireless controlling, wireless gateway of sort, you can do wired gateway and so on, right? We'll probably cover some of that in future, but I just want to kind of give you a kind of like a quick glimpse that how this architecture slightly differs from how we did it in other vendors, maybe like Cisco, right? Cool. So that being said, so I think one last thing I want to call out here is we spoke about whatever we spoke in a very general term, but when you look at the products, right? What one thing you need to be very careful is you need to be careful that the platform which you're going to use, you need to check if it really supports that kind of a deployment. Like for example here, the 7280s can be used only as head-end device. We spoke about head-end and the branch gateways, right? So you need to be careful. There are some products which you can use as both head-end and branch, whereas like for example 9004, which is the product which supports IDS and IPS, right? That supports only as a branch gateway. You can't use it as a head-end. Similarly, we are basically going to use virtual gateways in our labs, right, in the EVNG labs. Now ideally you should use them only as a head-end device, but we are going to use them as the branch gateway also. It is not officially supported, but we are going to use it because that's the only way I can create a virtual lab, right? But always make sure that you use this sizing table to understand which device is supported in which deployment mode, and what are some of the sizing charts over here, like for example maximum tunnels and so on, right? It's kind of important while you're designing this solution. All right, so one last probably thing is, maybe I think it's over here, which I want to cover is from a policies perspective, right? You've got again, maybe let me also show you the topologies. So they also have different type of topologies which you can create, right? The most common one obviously is the hub and spoke, which you see here, right, where the spokes can't talk to each other. All the traffic from the spokes goes to like a hub. It can be a regional hub or it can be like a universal hub, but yeah, so this is like one of the most common topology. You can also do, obviously you can do all types of redundancy. You can put multiple gateways at a branch, you can put a multiple gateways at the head end and all of that. We will talk about some of those deployments while we do the lab. But in addition to that, you also have some other deployments like a hub mesh, right? So you can see here, this could be a typical deployment if you're a very big enterprise, right? You might have a hub in Singapore, another hub in Sydney, another one in London, and you want like a full mesh, full routed mesh between them, so that you can send a lot of traffic between this. Maybe like a disaster recovery, right? You might have like 3 data centers where the hubs are located, and you want like a disaster recovery between them. You want to send a lot of terabytes of data between them. Then you want a full mesh of sort, right? So you can create that kind of a topology. Then you also have your branch mesh, right? So if you have a use case where you really want your branches to talk to each other, right, and kind of deviate from your typical hub and spoke, you can do that as well, right, using branch mesh. So you have such kind of multiple topologies based on your use cases. And one last thing which I want to cover here is policies, right? Just like any other SDN solution, here also you can create very extensive policies like shown here, right? You've got your typical policy based routing PBR, right, for doing things like direct internet exit, local breakouts and things like that, where you match the traffic based on certain classifiers, right? And then once you have matched the traffic, you can then decide what is going to be your next hop, right? So that's what you can do with PBR. QoS is very much important again, because we are talking about WAN here, right? So you really need shaping and policing to be done at your edges. So you normally do shaping at your edge as the enterprise edge, and then the service provider generally does some kind of policing. But yeah, if you have to do shaping, then you might want to also do some kind of marking and all the normal classification, marking and all of that, which we normally do in QoS, right? So all of that can be done here. Dynamic path steering. So this is again, if I want to take a resemblance here, right? The dynamic path steering is actually actually very similar to application aware routing, which we kind of did in Cisco's SD-WAN Viptela, right? So this is again something where you can kind of create SLAs, right, based on throughput, latency, jitter, packet loss, and then you can let the device, the branch device, decide what uplink it is going to use, which is going to meet these SLAs, right? So it's very similar to application aware routing, right? And then forward error correction, again creating when you're sending the traffic, you can insert some parity packets. That way you can reduce the number of retransmissions and all of that. Very much of a WAM optimization technology. And you also have SAS Express optimization. This is very similar to cloud on-ramps, right? So especially the SAS cloud on-ramp, which we already did in Viptela, right, where you can send certain probes, right, to some of the popular SAS applications, right, like DNS probes, HTTP probes, and then you can let your edge device decide which path it is going to use to talk to that particular cloud provider. So those are various policies which you can kind of set up in your SD branch solution. Perfect. So that being said, so we have now a little bit of understanding about why we need this solution, right? What is SD branch, why we need it, what are the various components of it, how the underlay is created, how the overlay is created, right? And we also talked about the policies part. We also talked about a little bit about the various types of topologies which you can create here, and the policies, right? The different types of policies, because that is the ultimate goal of SDN, right? You should be able to kind of steer your traffic with few clicks, right? You should be able to steer your traffic over MPLS or internet based on certain matching criteria. That is what you can do ultimately with most of the SD-WAN vendors, and that's what you can do here as well. Perfect. Moving on. So let's move on to my topology over here. So this is going to be the topology, right? Just to give you a quick understanding of everything here. This is going to be one of our branch, and we have two data centers here, right? Our branch gateways are here. We have two branch gateways. These are the Aruba's virtual gateways, and you also have the same virtual gateway here as the VPNCs, right? Ideally, we should use the virtual gateway only as VPNC and not as branch gateway. We are using it. It is not officially supported. We are using it because it is just a lab. Rest of the stuff is, again, you see you have like a L2 switch here, right? Internet switch, MPLS switch, which is basically where you have the multiple, which is ultimately connected to the internet ISP provider here. Similarly, you have the MPLS provider here. What I'm trying to do here is send all the internet traffic, right? I'm using EVNG's capabilities here to I'm basically natting all the traffic out to the internet, right? So that my VM over here has connectivity to the internet. Nothing very complicated. This, like, you have a lot of tutorials on how to do this, and I think EVNG documentation also kind of is pretty useful to do this. I also have like edge devices, like ISP devices, MPLS devices at each of the each of the VPNC. In this particular DC one, you will see a lot of extra devices, because I wanted to add more devices here to kind of show you BGP neighborships and so on. So you can see there is a DC1 switch, there is a DC core switch, and so on. This is just a L2 switch, because I have just one port here, so I wanted to put a L2 switch and use VLANs to kind of create two BGP neighbors, right? That's why I've added this L2 switch. Similarly, on the DC2 side, again, it's a small site, so I have just one DC core switch, and these are the subnets which are there at each of the sites, right? You can see various subnets at all the three sites. Ultimately, what we'll be doing is we'll be able to talk between these subnets, right? That is the whole goal. Bring this whole thing up, and then make sure that all of these guys are able to talk to each other. Then, obviously we will do some, policy-based routing. We will try to influence which uplinks the traffic is going to take, and all of that, all the fun stuff. That's what we'll be doing in the lab series, but I just wanted to give you an introduction of how this topology works. Okay. Now, the next important thing is, we will not mainly talk about the rest of the devices here, like for example the switches and routers. Those are, I believe I'm using virtual iOS or IOL routers here, right? Very straightforward stuff. We will not be talking about those things. I will provide the configurations of those devices on my GitHub repo once the whole series is done, so that you can use my EVNG file, you can use the configurations and start with the lab immediately. You don't have to figure out all the addressing and stuff. I will give you all of that. we will just concentrate about how to bring up a virtual gateway, right? So what do you need for this, right? So let me just grab the link for that. Okay, so if you actually go down to this, if you go down to this Eveng's documentation, right? There is a section for Aruba's mobility controller. So I followed the same procedure to kind of get the virtual gateways up, right? All you need is you need to go to asp.arubanetworks.com. This is where you can download all the software which you need. Basically, the virtual gateway. I'm using the 8.7 version for the labs. You can use 8.5, 8.6, or even the 10.x versions. Most of the stuff should be same, right? So this is where you will need to download the software from. I will not be able to provide the software because that would be kind of illegal. So if you don't have access to download the software, maybe reach out to your Aruba partners or Aruba account managers, and they should be able to help you kind of get the software and get you started to explore this technology. That being said, yeah, the process is pretty straightforward. You will be able to download a file which is very similar to this OVA file, right? And the OVA file can then be converted into like you see here. You'll basically, when you double click and open the OVA file, you'll get like two disks. One is your disk 1 and disk 2, and then you just need to use the same process here mentioned to create the two HDAs. And follow the naming convention and then move it, right? So once you do that, the device will show up. One interesting thing is, I don't know if I can, let me show you. So one important learning for me over here was once you go and add a node, like for example, the device which we are talking about is this one, right? And as you see, I'm using 8.7. But one important thing is make sure that you change the QEMU version to 4.1, right? Because if you don't do that, then you will find your devices sometimes getting stuck and so on. So I've had that issue, but once I moved it to 4.1, things were pretty simple, right? The next important thing is, yeah, you can use the RAM, Ethernet, and whatever I've used here. Always make sure you use just 4 Ethernets here, because the more number of interfaces you add, I saw that the device was not booting up. So I made sure that the interfaces were fixed to 4. And if you want to create more interfaces, you can use concepts of VLAN to kind of trunk the ports and virtually add more LAN ports, right? So you can use that logic, but make sure they use the port number to be 4. The next is the QEMU options, right? So at this moment, what I'll do is, let me just pause my video and let me just show you what exact QEMU options I use to make this work. Okay, so I've pulled up the QEMU options, right? So I'll obviously paste this in the description as well, but just want to kind of, all the 3 things should be in the same line, right? I've just broken it down to multiple lines just to show it to you. But the whole idea is that make sure you copy the exact QEMU options, right? And you might ask me a question, what is this CD-ROM, right? Because you see there is some kind of ISO file over here, and this is one other important thing for you to set up the lab, right? So you need this metadata file, right? And I'll tell you how to get it, but for a minute, right, just try to look at this one. Make sure you use the exact same QEMU options, otherwise things might not really work. All you have to do is copy the whole thing and then replace this section, which is the ISOs and the ISO folder and the ISO file. Basically, you will need to generate these metadata files from Aruba Central, and you need to upload these ISOs to your Evng, and then you'll just need to use the -cd-rom flag to point it to those ISO files. That's it, right? And I'll show you now how to generate those ISO files, right? So let me take a minute here. Okay, so I've got my browser here, right? So let's go to Aruba Central. So you can access it using common.cloud.hp.com, right? And then you need to put in your username and password. Now coming to Aruba Central, you might ask me, Joel, how do I get access to Aruba Central, right? Now if you just go and Google Aruba Central free, right? You will find okay, that's one sec. All right, I don't know why Google thought I was a robot, but anyway, so if you just Google for Aruba Central free, you'll probably find multiple links here telling you about a 90-day evaluation license, right, for customers who want to explore Aruba Central. So you can check out how to get it, right? So you should be mostly able to get a free Aruba Central for about 90 days. If you're not able to avail this, I would again suggest you to reach out to your Aruba partners or your Aruba account managers, and they should be able to help you kind of get this so that you can explore the technology and get your hands on. Right, once you're done with that, you will basically get something like this, right? So I'm using my personal email here, and I'm gonna sign in, right? You'll be able to create an account and sign in. Let's put my password here, and once you sign in, what you get is something like this. All right, so this is the view which you get with Aruba Central. You have a lot of things. For example, you can like for this particular account, right? This is just my lab account. I'm just playing around with it. So you can see, if you go to the devices, you will actually see the subscriptions and so on. When you create a evaluation account, you should get a few subscriptions for free, right? Maybe like very, very small quantity, like 2 devices, 5 devices and so on, just for you to explore the technology. Again, regarding this, if you don't have this, reach out to your Aruba contacts, and they might be able to kind of help you with getting you up to speed to kind of explore the technology, right? But that being said, let's go to the Aruba Central platform, which is over here, right? You will generally find there are a lot of other applications which you can use inside the HP ecosystem, but the main one which we are interested in is the Central. So I'm going to go to Central. So once you open up Central, you get something like this, right? Perfect. So here, all you need to do is come to this section. So right now, I have cleared out all my, sites and groups and everything, whatever was there in Central. So it's completely blank. I'm going to go to network services over here, right? And go to virtual gateways, right? Go to manual. And over here, I can generate those ISO files, which I talked about, right? So here, you can see right now there is nothing, right? So I'm going to go to config here on the top right, and go to manual again, and here you can see these are some of the, so I have I'm allowed to create 4 gateways, right? I can create 4 gateways of each types, right? Again, for the lab purpose, I can use just the 500 MB because I don't think I'll be even sending 500 Mbps. But again, you have different virtual gateways based on the throughput which they can give you, like 2 gig, 4 gig and so on. You can use any of those, but I'll be using just the 500 MB ones. So I'm going to select it, and I'm going to say create device identity, and it's going to ask you. I'm going to say yes. Right, so there you go. So it created. It's going to take a few seconds. Right now it's in the init state. Let's come back after probably a minute. Perfect. So once it is generated, now you see you get something like this: user data generated, right? All you have to do is go here and click download ISO. So once you have that ISO file, next what you need to do, you need to upload this ISO file to your EVE-NG VM. So what I'll do is, let me do that. There you go. So I've pulled up my FileZilla, where I'll be uploading this so that I can show it to you, right? Let's go to the location. Which location? So I'm going to go to OPT, Unilet, add-ons, QEMU, and inside QEMU I have created a separate folder for ISOs, and here from the reference file, let's refresh it. So there you go. That's the file I downloaded. I'm just going to upload it, right? And the file is already uploaded. So now that once you have that, all you need to do is, right, copy the name of the file. In this case, I'm just going to copy it from here, right? Let's go to that, let's go to our text editor. What I'm going to do now is just replace this with the name of the file, right? The ISO file which I generated. And now you just need to copy the whole thing, right? Let's actually make sure that this is in the same line. So I'm gonna send it to the same line, right? There you go. Now I'm gonna copy the whole thing, Control C, and let's go to our EVE-NG over here. Where is our EVE-NG over here, right? You just need to replace it over here, paste it. That's it, right? Paste it, save it, and then one of the devices up. That's it. I mean, that's all is needed for you to get the device up, right? So that but you need to generate separate ISO files for each of your devices. Obviously, whatever I showed you was for one device, But for the second device, again, you have to do the same process. Go and generate the second ISO device, ISO file, put it into your EVE-NG, and update the QEMU options on that device. So I will be doing that for all the 4 devices, but in the video I just showed you for one of the device, right? So yeah, that's everything which I wanted to show you before we start with the actual hands-on in the next video. Right, so just to recap, what did we do today? We kind of started with getting a quick overview of the solution, right? What Aruba SD branch is all about, what are the various components, what are the various topologies you create with it, what are the various types of policies, and so on. Then we looked at our lab. We tried to understand how this lab is set up, what are some of the prerequisites, what are some of my learnings which you can use to kind of bring up the lab quickly. So yeah, I think hope that was useful. Do come back on the next video where we'll be discussing more on some of the actual hands-on exercises. Okay, ciao, bye.